sources, we have seen that independent sources are those sources which don't depend on any other circuit parameters. Okay, dependent sources depend on the other circuit parameters. And what are the circuit parameters? Circuit parameters are current through any branch or voltage across any two terminals in your circuit. Okay, so if any voltage source or current source is depending on any other circuit parameter, that will be in the category of dependent source. Okay, so that we have already gone through all these things. We have also seen that how we can convert from one source to another source, means source conversion we have seen. From voltage source to current source, how we can convert. From current source to voltage source, how we can convert. Okay, after that we have also seen the star delta conversion in the last lecture. Star delta conversion or delta star conversion means, if in the circuit, if we found that there is no possibility of series and parallel combination, okay, means we cannot deduce the element values, equivalent resistance, equivalent inductance, or equivalent capacitance, or equivalent impedance. So in that case, if there is no combination of series and parallel we will found, then we can use the terminology of star and delta. We will find whether in the circuit there is a structure of a star or delta. Then if we convert it into the other form, and if we are able to deduce the circuit or simplify the circuit, then we will use that one property. Okay, if there is a star connected network in the circuit we found, and if we convert into delta, so we will convert it and we will use it. Okay, similarly, if there is a delta connected network in the circuit, and if we found that if we convert into a star, and that will make the series parallel combination, so we can use that one. Okay, we have opportunity for that. So that's why we have studied various fundamental concepts before starting our actual circuit solving concept. So before circuit solving concept, we will see some terminology in network or circuit. Okay, so in that we can see that in here you can see that first terminology is node, then branches, then loops, and meshes. Okay, so in figure 1 you can see that this is a simple resistive network. In that resistive network you can see that this point A, point B, point C, and point G, these are the nodes. Okay, so what is the definition of node? The definition of node is, the node is an in an electric circuit is a point where two or more components are connected together. Okay, so the node is a point where two or more components are connected together. So why the point A is node? Because you can see that there are three components connected together with this node. Okay, R1 resistor R1 is connected with this node A. This voltage source is connected with this A together with series connected resistance, and this voltage source VA is also connected with this node. So together with this node, there are three branches connected. Okay, These all are called branches. We will see next what is the definition of branch. So node is a point where two or more components are connected together in a network or circuit, right? So in a circuit, among all nodes, while circuit solving, we will make a separate node as a reference node. Okay, reference node means we will assume the voltage at this node 0. Okay, you can see that here ground is connected. When ground is connected, the voltage at this node is 0. Okay, so this is assumed as a reference node. This is assumed as a reference node. So next is branch. So what is the definition of branch? Branch is a conducting path between two nodes in a circuit containing electrical elements. So branch is a simply connecting path or conducting path between two nodes. You can see that here node A and node C. In between node A and node C, you can see that this element is connected, R1 is connected. So AC is a branch. Okay. AC is a branch which is connected between two nodes. Okay. Means it is a conducting path between two nodes simply. Okay. You can see clearly between A and G, you can see that the voltage source is connected. So this is also an element. This is an active element. So in between A and G, between two nodes, this source is connected. So this is also a branch. Okay. So similarly, how many branches are there in this figure 1? Can anyone tell how many branches are there in this figure 1?
Six.
1, 2, 3, 4, 5, 6. Right? This one is the first branch. This is second branch. This is third branch, fourth, fifth, and sixth. So there are 6 branches. Total 4 nodes are there. Okay. So 3 resistive branches. You can see AC, BC, BG. This is AC, where resistance R1 is connected. BC resistance R3 is connected, and BG, this resistance is connected. The value is not mentioned here. And 3 branches containing voltage and current sources. So you can see that AB, in this branch, this voltage source is connected. AG, this voltage source is connected, and CG, this voltage source is connected. Okay. So total 6 branches are there, 4 nodes are there. Now next is loop. What is loop? Loop is any closed path in an electric circuit. Okay, so the only condition is that two or more nodes should be touched while moving towards in a loop. Okay, so you can see that the loop is any closed path in an electric circuit, and that is a closed path or loop in a circuit is a contiguous sequence of branches which starting and end points for tracing the path are in effect the same node and touches no other nodes more than once. Okay, so it means if we start at this node and if we reach by moving towards this area, if we are reaching at the same node, so this will be a loop. Okay, simply it is a closed path in a circuit. Okay, so this is a loop. In this loop, you can see that there are three nodes connected, A, B, and C, A, B, and G. So in this loop, it is a closed path, and current can flow in this loop. So in this closed path, there are three nodes connected, A, B, and G, and no node is traced more than once. Okay, means जब हम इस लूप में आगे बढ़ेंगे तो कोई भी एक नोड दो बार नहीं आना चाहिए, राइट? मीन्स एक ही बार आना चाहिए, एक से ज्यादा बार नहीं आना चाहिए। जैसे यहाँ पे एक एलिमेंट है, ओके, इसी नोड के इर्द गिर्द है। सो अगर हम ये इसको लूप कंसीडर करेंगे तो ये लूप नहीं होगा, क्योंकि ये नोड बी दो बार आ गया। ओके, एक बार तो इस लूप की वजह से आएगा और एक बार जब हम इसमें मूव कर रहे हैं उसकी वजह से। सो कोई भी नोड एक ही बार ट्रेस होना चाहिए, मतलब अगर हम इस लाइन में मूव कर रहे हैं तो एक ही बार वो नोड आना चाहिए, तभी वो लूप कंसीडर किया जाएगा। सिमिलरली एक ये लूप है और एक ये लूप है। ओके, और कोई लूप है क्या इसमें? इज देयर एनी अदर लूप इन दिस सर्किट, इन दिस
No,
फिगर?
sir.
Is there any other loop?
No, sir.
There may
बड़ा
be,
वाला भी ब्रेक होगा सर,
okay,
बड़ा वाला
more
पूरा।
than three loops. Why more than three loops will be there? This outer one will also be a loop. यहाँ से स्टार्ट करेंगे, ए से चलेंगे, सी पे आएंगे, जी पे आएंगे, वापस ए पे आ जाएंगे। कोई भी एक नोड दो बार नहीं आ रहा है। ओके, ए से स्टार्ट किया, सी पे गए, जी पे गए, वापस ए पे आ गए, तो ये भी एक कनेक्टेड पाथ है। इट इज ऑल्सो अ लूप, आउटर लूप, राइट? So this outer loop is also considered as a loop. और कोई लूप है इसमें?
सर नीचे वाला, नीचे के जो दो हैं उनको मिला के एक और लूप बनेगा।
इन दोनों को मिला के एक लूप बन सकता है। हम ए से स्टार्ट करेंगे, बी पे जाएंगे, सी पे जाएंगे, जी पे आएंगे, वापस ए पे आ जाएंगे। ओके, सो ये वाला एक लूप हो जाएगा, नीचे वाला दोनों लूप मिला के। सो अगर ये लूप 1 है, ये लूप 2 है, ये लूप 3 है, सो ये आउटर वाला एक इनसाइड होगा, एक ये आउटर है, आउटर वाला लूप 4 होगा, और इनसाइड वाला ये दोनों लूप 1 और 2 को मिला के एक लूप 5 होगा। ओके, टोटल 5 लूप्स।
सर 1 3 मिला के
सर 1 3 और 2 3 मिला के भी दो लूप्स बन सकते हैं।
1 3, हाँ ये भी बन सकता है, यस ये भी बन सकता है। वेट, एक कॉल आ रहा है। Okay. So yeah, there are more than 5 loops also. Okay. So इसको 1 और 3 को मिला के भी एक लूप बनेगा, 2 और 3 को मिला के भी एक लूप बन जाएगा, राइट?
यस सर।
तो 7 लूप तो ऐसे सीधे सीधे दिख रहे हैं, 1 2 3 तो स्टार्ट एकदम क्लियर है, 1 2 3 तीनों को मिला के एक लूप बन रहा है। ओके, 1 2 को मिला के एक लूप बन रहा है, 1 3 को मिला के बन रहा है, 2 और 3 को मिला के बन रहा है, राइट?
यस सर।
सो लूप का डेफिनेशन क्या होगा? लूप इज एनी क्लोज्ड पाथ इन अ सर्किट। सर्किट में कोई भी क्लोज्ड पाथ बन रहा है वो एक लूप हो जाएगा। ओके, मेश क्या है? मेश इज ए स्पेशल केस ऑफ लूप। Mesh is a special case of loop that doesn't have any other loops within it. इसके बीच में कोई और लूप नहीं होगा, राइट? सो इसमें इस सर्किट में कौन कौन मेश हो जाएंगे?
1 2 3।
1 2 3। सो इट मीन्स कि मेश टोटल 3 है, जिसमें लूप 1 2 और 3 ये तीनों मिला के 3 मेश होंगे, राइट? तो इससे क्या समझ में आ रहा है कि लूप तो बहुत सारे हो सकते हैं, बस मेश जो है वो स्पेसिफिक होगा, जिसमें और कोई इनसाइड कोई और लूप नहीं होगा। किसी भी लूप के अंदर इनसाइड कोई और लूप ना हो, वही मेश कहलाएगा, राइट? सीधा सीधा ये डिफरेंस है दोनों में। इट मीन्स वी कैन से दैट,
सर
हाँ,
सर 1 और
1 और
1 and 3 and 2 and 3।
1 and 3, 1 and 3, 2 and 3,
यस सर।
ये क्या मेश होगा?
उसमें भी कोई अंदर एक लूप नहीं आ रहा ना?
नहीं नहीं, एक्चुअली क्या है, 1 और 3 ऑलरेडी अपने में लूप है, तो दोनों को मिला के हम मेश नहीं बना सकते। ओके,
ओके
हाँ।
ओके सर।
तो इंडिविजुअल लूप्स होंगे, जिसके अंदर कोई भी अदर लूप नहीं आ रहा है, वही मेश होगा, राइट? सो इट मीन्स कि वी कैन से दैट एवरी मेश इज अ लूप, बट एवरी लूप कैन नॉट बी ए मेश। ओके, एक सिंपल वर्ड में बोला जा सकता है। ये समझ में आ गया डेफिनेशन नोड्स का, ब्रांचेस का, लूप का और मेश का?
यस सर।
ठीक है।
यस सर।
इसका यूज होगा आगे सर्किट सॉल्विंग में। अब हम मेन टॉपिक पे आएंगे, जिसमें हमें सॉल्यूशन फाइंड आउट करना होगा। सॉल्यूशन ऑफ इलेक्ट्रिक सर्किट मीन्स वी विल नाउ सॉल्व एनी सर्किट। Okay, we will find out the solution of any circuit. Finding the solution of circuit means we have to find out the voltage and current values. That's it. Okay. जैसे KVL और KCL, किरचॉफ्स करंट लॉ एंड किरचॉफ वोल्टेज लॉ, ये दो फंडामेंटल लॉ हैं। इनकी हेल्प से हम वोल्टेज और करंट फाइंड आउट करते हैं, राइट? आपने 11 12 में भी इसको किया होगा। तो KCL KVL तो पहला सर्किट सॉल्विंग के लिए तो फंडामेंटल प्रिंसिपल आपको किरचॉफ्स लॉ से मिलता है, राइट? उसको हम रिवाइज करेंगे। सो फर्स्ट एंड फॉरमोस्ट सिंपल वे टू एनालाइज एनी सर्किट इज किरचॉफ्स लॉ। नेक्स्ट इज मेश और लूप मेथड, another one is nodal method, and then we will move towards network theorems. They are very popular. Network theorems are very popular and very effective to simplify any complex circuit in a simpler way. Okay. सो होगा क्या, जैसे किरचॉफ्स लॉ हम कहाँ पे किरचॉफ्स लॉ में कॉम्प्लेक्सिटी आएगी? किरचॉफ्स लॉ का लिमिटेशन क्या है, किसी को मालूम है? By using simple KCL KVL also we can find out the value of voltage and current, लेकिन लिमिट क्या है? सर्किट सिंपल है तब इजी होगा सॉल्व करना। अगर सर्किट बहुत कॉम्प्लेक्स है, अगर सर्किट में प्लेंटी ऑफ एलिमेंट्स कनेक्टेड हैं, ओके, सर्किट बहुत कॉम्प्लेक्स है, सो सिंपल KCL KVL अगर यूज करेंगे तो नंबर ऑफ इक्वेशन ज़्यादा बनेंगे, राइट? सर्किट में करंट और वोल्टेज फाइंड आउट करना किसी भी ब्रांच के लिए डिफिकल्ट होगा। क्लियर? तो वहां पे फिर नेटवर्क थ्योरम्स का हेल्प आएगा। नेटवर्क थ्योरम की हेल्प से हम सर्किट को, किसी भी कॉम्प्लेक्स सर्किट को हम सिंप्लीफाई कर सकते हैं, सिंपलर वे में हम जल्दी आंसर पा सकते हैं। ओके, सो फर्स्ट वी विल सी किरचॉफ्स लॉ और we will revise this one. You have already studied, so this will be just a recap for you. There are two Kirchhoff's law, that KCL Kirchhoff's current law and KVL Kirchhoff's voltage law. What is the statement of KCL? KCL will be applied at a node, okay, at any node or junction. So as per the statement of KCL, the algebraic sum of currents entering and leaving a node at any instant of time must be equal to 0, right? As per the KCL, algebraic sum of all currents at the node must be 0. Simple, पढ़ा हुआ है पहले से, okay? So currents entering and leaving at the node, the algebraic sum of all currents entering and leaving at the node must be 0, okay, at any instant. So there is some passive convention. The current entering will be denoted by positive sign, current leaving will be denoted by negative sign, okay? The node must assign opposite algebraic signs. So it means in this figure A, you can see that this is a node, and this can be a part of any circuit, okay? Suppose in a complex circuit, we have taken a node and branches connected with this node we have taken. So in these branches, at this node, there are 1, 2, 3, 4, 5, 6. 6 branches are connected, and the current flowing through these branches is also given, and the direction is given. Here direction is downward, upward. Okay, means towards the node. This is entering to the node. This is leaving to the node. This is also entering to the node. This is leaving to the node. This is entering to the node. This is leaving to the node. So there are 1, 2, 3. 3 currents are entering to this node, and 3 currents are leaving to this node. Okay. So how we can write the KCL? Means we have to make an equation. We have to make the algebraic sum of currents entering as well as current leaving to this node, and that will be 0. Okay. So we know that this is I1. I1 is current entering to this node. So we have taken currents entering as a positive sign. So if we write KCL equation, so we will take plus I1. Then where is I2? This is I2. This is leaving to this node. So for leaving, we have taken minus sign, minus I2. Then I3 is entering, plus I3. Then I4 is leaving, minus I4. Similarly, we can write I5 plus I5, I6 minus I6, and that will be 0 as per the statement of KCL. So it means I1 plus I3 plus I5, that is equal to I2 plus I4 plus I6, right? I1, I3, I5, those are current entering to this node. I2, I4, I6, current leaving to the node. So means, as per this statement, incoming current to this node is equal to outgoing current. Incoming currents is equal to outgoing currents. Simply, okay. Next is KVL, Kirchhoff's voltage law. It states that the algebraic sum of all voltage sources must be equal to the algebraic sum of all voltage drops. Means voltage drop means, where will be the voltage drop? Voltage drop will be across any element. Okay, means in a loop, it will be applied in a loop. You know that KCL is applied at the node, KVL will be applied at the in a loop. Means in a loop, if there are some sources, so algebraic sum of all sources will be equal to algebraic sum of the voltage drop across elements. Okay. And you know that the voltage drop is encountered when the current flows in an element from higher potential towards the lower potential. This is very much important. Suppose this is an element in a branch. Suppose this is an element in the branch, and polarity we have taken plus minus. Okay. So the current must flow from higher potential to lower potential in this element. That's why the polarity, that is voltage drop across this element, will be plus here, minus here, Vz. Okay, voltage drop will be encountered when the current will flow from higher potential to the lower potential. Clear? However, if you will see in any source, अगर ये वोल्टेज सोर्स है तो करंट कहां से कहां की तरफ फ्लो करता है? वोल्टेज सोर्स में करंट कहां से कहां की तरफ फ्लो करता है? हायर पोटेंशियल टू लोअर पोटेंशियल और लोअर पोटेंशियल टू हायर पोटेंशियल?
Sir, higher to lower.
Hmm.
Higher to lower, sir.
सोर्स में, वोल्टेज सोर्स में हमेशा करंट जो फ्लो करता है वो नेगेटिव टर्मिनल से पॉजिटिव टर्मिनल के साइड में जाता है, राइट। मीन्स लोअर पोटेंशियल टू हायर पोटेंशियल करंट फ्लो करेगा। सो इसमें जो करंट फ्लो होगा, करंट का डायरेक्शन लोअर पोटेंशियल टू हायर पोटेंशियल रहेगा, और यही करंट किसी एलिमेंट के क्रॉस दिया जाएगा। मान लेते हैं सेम एलिमेंट को यहाँ दे रहे हैं, तो सेम करंट यहाँ पे आएगा इस डायरेक्शन में, ओके। सो इट मीन्स voltage across that element, the polarity will be plus here minus here. This is Vz. पोलैरिटी यहाँ पे प्लस होगा, यहाँ माइनस होगा, और करंट का डायरेक्शन हायर पोटेंशियल टू लोअर पोटेंशियल होगा, ओके। सो इट मीन्स वोल्टेज ड्रॉप Vz आएगा, उसका पोलैरिटी हम कैसे डिसाइड करेंगे? उसका पोलैरिटी हम करंट के डायरेक्शन से डिसाइड करेंगे, राइट। सो अगर एलिमेंट है तो वोल्टेज ड्रॉप प्लस यहाँ होगा, माइनस यहाँ होगा, करंट का डायरेक्शन हायर पोटेंशियल टू लोअर पोटेंशियल साइड में होगा। अगर कोई सोर्स है जो एनर्जी डिलीवर कर रहा है, एनर्जी सप्लाई कर रहा है, वो एनर्जी सप्लाई करेगा हमेशा नेगेटिव टर्मिनल से पॉजिटिव टर्मिनल के साइड, मीन्स लोअर पोटेंशियल टू हायर पोटेंशियल। एनर्जी रिलीज कर रहा है ना, सोर्स है तो, राइट। समझ में आया?
Yes, sir.
So according to the KVL, you know that KVL will be applied in a loop, okay. So in a loop, when we will apply KVL, so you can see the example B here. In a loop, in this loop there are many elements, some resistances are there and some voltage source are there, okay. You can see 1 2 3 4 voltage source are there, and 1 2 3 4 5 elements are there, okay. And we have to apply KVL in this loop. KVL will be applied in a loop. So in a circuit, you will have many loops, and if you have to identify the value of current in a loop, so you have to first denote the currents, and then you have to apply KVL, and you will find, as per the loop, you will find different KVL equations, and then you have to solve KVL equations, and you will get the required value of current in any loop, okay. So in figure B, you can see that this is a loop. There are 4 voltage sources connected in this loop and 5 resistances are there, okay. So you can see that the current direction is taken in the clockwise, okay. Current flowing through the closed path, it is mentioned here I, it is denoted by I. So in KVL, while applying KVL, we have to calculate the voltage drop across elements, and we have to take the algebraic sum of voltages of the sources also, okay. So here, if you'll apply KVL, we can start at any point, okay. If suppose I am starting at this point, so when I will start at this point, I will complete this path, and I will reach to this point, okay, while calculating the all voltages in this loop. So how we can write the KVL equation of this loop? There is a passive convention here. If we are going from positive to negative, we will take negative sign. Okay. If we are going from negative to positive, we will take positive sign. This is a simple passive convention. You can take opposite also. Means while going from positive to negative, you can take positive also. And while going from negative to positive, you can take negative also. Okay. But generally, while going from positive to negative, negative is taken. And while going from negative to positive, positive is taken. So we will write KVL equation. So we are starting at this point. First we are getting plus sign, then minus sign, and it is an element. So voltage across this element will be, due to moving towards positive to negative, we will take negative sign, minus I into R2. That will be voltage drop across this resistor. Current I is the current flowing through this loop. So minus I into R2 is the voltage drop across this resistor. Then again we are getting plus sign here, then minus sign. So we are moving from plus to minus. It will be again minus. So minus of V2 because it is a voltage source. Then again we are getting plus here, minus here, minus I R3. Then again we are getting plus minus, minus I R4. Then we are getting minus and plus. So again, now it will be plus sign. First we are getting minus sign, then we are getting plus sign. It will be plus V3. Then again we are getting plus minus, means minus I into R5. Then again we are getting minus plus. It means we have to take plus V4. Then minus to plus V1, and then plus to minus I into R1, and that will be 0. Means algebraic sum of all voltages in a loop will be 0. In that voltages, some will be voltage across elements and some will be actual voltages due to voltage sources. So clear? Is it clear to all of you how we are applying KVL in a loop? Is there any doubt?
No, sir.
Okay. So if we can rearrange this equation, you can see that V1 is here. V1 minus IR1 is here. V1 minus IR1 minus IR2 minus IR2 you can see here, minus IR3 minus IR4 plus V3 minus IR5 plus V4, that is equal to 0. So this is the KVL equation. And if we separate voltage source values and voltage drop across elements, so you can write V1 minus V2 plus V3 plus V4 is equal to IR1 plus IR2 plus IR3 plus IR4 plus IR5. Okay. So this will be this will make a equation. So in summary, you can say that KVL will be applied in a loop, KCL will be applied at a node. Okay. And KCL is the algebraic sum of all currents, whether it is entering or leaving to the node, will be 0. Algebraic sum of currents entering and leaving to the node is 0 as per the KCL, whereas as per KVL, algebraic sum of all voltages means voltages due to voltage sources and voltage drop across the elements, that will be 0. Algebraic sum of all voltages or voltage drops in a loop will be 0 as per KVL. Okay. So here you can find some examples, and by using these examples, I have given assignment 1 to you. I think all of you got it because I have uploaded assignment on Google Classroom. So have you received assignment in Google Classroom?
Yes, sir.
Yes. So you have to solve those assignments in a separate copy, and you have to take photo of those solutions, and you have to make a single PDF file and you have to upload as per your answer. Okay. And you have to rename the file as per your roll number and name that I mentioned in the instruction. Okay. So you have to follow, you have to rename your PDF file and then you have to upload. So next method. Have you studied anytime mesh and nodal method? Mesh method and nodal method? No?
And not mesh method.
मेश मेथड पढ़ा हुआ है क्या? नहीं पढ़ा हुआ है?
No, sir.
Okay. Okay. So from here onwards, your main topic will start that you have not studied yet. Okay. So mesh method, or it is also called as a loop method, or it is also called as a mesh current method. Okay. So mesh method means, you know what is mesh? Okay. Mesh is a individual loop where inside the mesh there should not be any other loop, right? So in a circuit, firstly you have to find out the number of meshes, and then you have to define the current flowing that meshes, means in mesh is itself a loop. So current flowing in the loop you have to identify, just like in figure 3 you can see that the current flowing in this loop is loop 1, and that is defined as I1. Current flowing in the loop 2 is I2. Current flowing through the loop is I3. Okay. And the current flowing, direction of current flowing, you have to assume as per your choice. You can take any direction. If your assumed direction is correct, okay, the current value will be positive. When you calculate the current value, it will come positive. If your assumed direction was wrong, you will get negative value of that current. Means you have to reverse the direction of current. Okay, that will be the simple principle. So in mesh method or loop method, you have to firstly identify the number of meshes, then you have to denote the loop currents in that. Okay, in this circuit you can see that there are 3 meshes. Okay, just like we have seen in the previous diagram, figure 1, where we have seen that 3 meshes are there, but the more than 3 loops are there. So we have to take meshes only because this is a mesh method. So we have to define first the number of meshes. Here in this loop, in this circuit, there are 3 meshes. So we have to apply KVL in that meshes. Okay, we have denoted the current direction in this message, okay, and it's better to take same current direction. If you are taking clockwise direction, please take clockwise only, because you will be confused, okay, while writing the KVL equations. So to make the KVL equations, to write KVL equations in an easy manner, you have to take same direction, okay, and it's better to take clockwise direction for all loop currents, okay. So loop current I1, I2 and I3, you can see that all direction are clockwise only. So as per the KVL equations, you know that the KVL equations are written in a loop, okay, and there are 3 loops in this circuit. So there will be 3 KVL equations, right? You have to write 3 KVL equations. And we know that I1, I2, I3, we have assumed, we don't know the value of I1, I2, I3. So it means there are 3 variables here, I1, I2, I3, and we have to write 3 KVL equations by writing the KVL equations in the loops. So we will have 3 KVL equations. We have 3 variables. So by solving those equations, we can easily get the values of I1, I2 and I3. This is the basic principle of mesh method, and this is also procedure to apply mesh method or mesh current method. Clear?
Yes, sir.
So सबसे पहले हमको ये देखना है कि कोई भी सर्किट जो दिया गया है उसमें कितना मेश बन रहा है। अगर मेश बन रहा है तो उसमें हमको लूप करंट एज्यूम करना है और करंट का डायरेक्शन हमको सेम लेना है, ओके। क्लॉकवाइज डायरेक्शन लेना ज़्यादा बेटर होगा, उसमें सिंप्लिसिटी रहेगा केवीएल इक्वेशन लिखने में। सो यहाँ पे हमारे डायग्राम में फिगर 3 में आप देखेंगे कि 3 मेश बन रहे हैं, दिस लूप 1, लूप 2 एंड लूप 3। इन तीनों में हमको क्लॉकवाइज डायरेक्शन एज्यूम करते हुए करंट का डायरेक्शन I1, I2, I3 ले लेना है, ठीक है। उसके बाद हम जानते हैं कि केवीएल हमारा लूप में ही अप्लाई होता है, ओके। तो ये तीनों लूप हैं, तीनों लूप में हम अलग अलग केवीएल इक्वेशन लिख लेंगे, ओके। जैसे हम केवीएल अभी तक सीखते आए हैं वैसे केवीएल हम अप्लाई करेंगे तीनों लूप में। और ये हमारा तीनों जो करंट का वैल्यू है I1, I2, I3 लूप करेंट्स, ये अननोन है, हमको पता नहीं है। तो तीनों इक्वेशन जब लिख लेंगे और 3 हमारे पास अननोन है, तो हम जानते हैं कि कोई भी लीनियर इक्वेशन है, नंबर ऑफ इक्वेशन उतने होने चाहिए जितने हमारे पास वेरिएबल है। तो हम उन वेरिएबल का वैल्यू फाइंड आउट कर सकते हैं इजीली उन इक्वेशंस को सॉल्व करके। वही सेम प्रिंसिपल यहाँ पे हम अप्लाई करेंगे। क्लियर? सो अब आपको मेन टास्क क्या है, इसमें मेन चैलेंज है कि केवीएल इक्वेशन लिखते टाइम कोई मिस्टेक ना हो, ठीक है। इस पे विशेष ध्यान देना है। यू हैव टू take special attention while writing KVL equations, okay, because when your KVL equation will be wrong, your answer will be wrong, okay. It will make your answer wrong for whole currents, okay, whether it is I1, I2, I3, all will be wrong. So इसमें यही ध्यान देना है कि हमको KVL इक्वेशन लिखते टाइम पे कोई मिस्टेक नहीं करना है, ओके। इट मीन्स कि केवीएल अप्लाई करने ढंग से आना चाहिए। सेम इसका जस्ट अपोजिट है जो नोड मेथड हम पढ़ेंगे। नोड मेथड में हमको नोड पे इंडिविजुअल नोड सबसे पहले हमको देखना है कि कितने नोड हैं सर्किट में, उसमें से एक नोड को रिफरेंस नोड मान लेना है जैसे हमने बताया। उसके बाद जितने नोड बचेंगे वो सारे नोड पे हमको नोड वोल्टेज एज्यूम करना है और उन नोड्स पे हमको केसीएल अप्लाई करना है। सो नोड वोल्टेजेज वहाँ पे वेरिएबल रहेंगे और केसीएल इक्वेशन लिखने के बाद हमारे पास जितने नोड वोल्टेजेस होंगे, जितने नोड्स होंगे, उतने केसीएल इक्वेशन मिल जाएंगे। और उन इक्वेशंस को सॉल्व करके, क्योंकि हमारे पास नंबर ऑफ इक्वेशन उतने ही होंगे जितने नंबर ऑफ वेरिएबल्स हैं, मतलब नोड वोल्टेजेस, सो उनको सॉल्व करके हम वैल्यू फाइंड आउट कर सकते हैं नोड वोल्टेजेस का। सो एक में केवीएल अप्लाई करना होता है, दूसरे में केसीएल अप्लाई करना होता है। नोडल मेथड में केसीएल अप्लाई करना है, मेश मेथड में और मेश करंट मेथड में केवीएल अप्लाई करना है, क्योंकि केवीएल लूप में अप्लाई किया जाता है, केसीएल नोड पे अप्लाई किया जाता है, राइट। ओके, सो बाकी डिस्कस करेंगे नेक्स्ट क्लास में, तब तक मैं अटेंडेंस ले लेता हूँ। ओके ओके, हाउ many if you have difficulty in understanding हिंदी? किसी को हिंदी में प्रॉब्लम है समझने में? अगर किसी को है तो बता सकते हैं।
नहीं सर, कोई प्रॉब्लम नहीं है।
हाँ ठीक है, क्योंकि मुझे लगता है कि बीच बीच में थोड़ा हिंदी बोलने से ज़्यादा समझ में आएगा अच्छे से, राइट।
Yes, sir.
यस
Sir,
हम्म
sir, I have a problem in Hindi. I'm from South actually.
ओके ओके, so till now I am talking in English only. In between, for some time, to explain better, I will use Hindi. Okay, so
Okay, sir.
if you have any issue in that understanding any concept, you can ask anytime. Okay,
Yes, sir. Yes, sir.
there is no foundation. Thank you.
Thank you, sir.
I am telling your attendance: Ashish Chandra, Avya Chandra,
Present, sir.
Aditya RS,
Present, sir.
Akash Srivastava,
प्रेजेंट सर।
Akhilesh Sahu,
Present, sir.
Akshay Taneja, Anand Mawat,
प्रेजेंट सर।
Ankit Das,
प्रेजेंट सर।
Apurva Raj, Arnav Kumar,
प्रेजेंट सर।
अविनाश कुमार सिंह, आयुष कुमार सिंह,
Present, sir.
गौरव तिवारी,
प्रेजेंट सर।
ईशान सिंह, कृष्णा गुप्ता, मैत्री उपल,
Present, sir.
मुद्रा गुप्ता,
Present, sir.
प्रांजय सोनी,
Present, sir.
प्राची गौतम,
Present, sir.
प्रज्वल सिंह,
प्रेजेंट सर।
प्रियांश राज,
यस
प्रियांशु कुमार,
प्रेजेंट सर।
पुलकित सिंह,
Present, sir.
राहुल, राजीव कुमार पांडे, ऋषभ आर्या,
Present, sir.
रोहन कुंतल, एस ऋतिक साय,
Present, sir.
साकेत सुमन, सम्यक कश्यप, संग्राम चक्रवर्ती,
Present, sir.
शशांक त्रिपाठी,
प्रेजेंट सर।
शुभम रंजन,
प्रेजेंट सर।
शुभम सिंह,
Present, sir.
श्रवण स्वरांकर,
प्रेजेंट सर।
सुधांशु कुमार,
Present, sir.
सुजीत कुमार, सुमित सिकरवार, सुप्रिया,
Present, sir.
सूर्यांश वर्मा,
प्रेजेंट सर।
उज्जवल नयन,
प्रेजेंट सर।
उत्कर्ष कुमार यादव,
प्रेजेंट सर।
वैष्णवी,
Present, sir.
वेदांशी, विशाल वेस्ले,
Present, sir.
यश बावस्कर,
Present, sir.
अर्णव कुमार, विनीता वाटिया,
Present, sir.
संभवी श्रीवास्तव, शशि शेखर मिश्रा। Okay, any other? Okay, then you can leave the meeting and we will again meet in the next class tomorrow.